built up section means a member which is made up of two different sections, two or more. Okay, it means you can use two angle sections, two channel sections, then two eye sections. These sections can be again added with some cover plates and so on. Okay, so how to design such built up sections, that we shall see. The design steps are similar to the previous one that we have already seen. So here, first step is, as usual, calculate the factored load to which the column is subjected. Okay, now knowing the support conditions, determine the unsupported length of the column and slenderness ratio. So referring the tables in IS 800, we have to first of all find what is effective length using boundary conditions, and then slenderness ratio, KL by R minimum. Okay. Next step will be, we have to assume RXX. So for assuming the RXX, if you are selecting ISHB, ISSC, ISWB, what is this? ISHB is an I section, ISSC is a channel section, ISWB is a wide eye section, okay, having slightly more dimensions than ISHB. Then for such a group of sections, RXX can be assumed between 50 to 30. And for ISMB, medium beam, we can assume it as 40 to 20. Okay, so this is important. Then next step will be calculate slenderness ratio and obtain approximate design stress for buckling class C. Why? Because we are only using I sections, and I sections as per the section classification lie under buckling class C. So you calculate slenderness ratio and obtain approximate design stress FCD value for buckling class C. Then check whether I section of required area is available. If not, it may happen that the required area is not available in the sections. Then what you can do is, you can add some additional parts to the selected section and you can increase the area. It means I section with cover plate or channel section with cover plate. Then design the section RYY of pleated section, and this should be more than R value of I section. Okay, it means compound section will have different RYY value, and this should be more than RYY value of I section selected from the field table. If load is very heavy and pleated section is insufficient, then try compound section. It means you can use double section, double I section, double channel section. Then select two channels face to face or back to back, anything. If you are selecting channel sections, then RXX value will be in the range of 154 to 90 for Indian standard light channel, okay, and Indian standard standard channel. Then Indian standard medium channel is the second row, where depth is 200 to 400 for both the categories. Then you will select RXX as either 154 to 90 or 154 to 118. These are just the recommended values. Okay. Then you calculate again slenderness ratio and obtain FCD from table 9C. Now it is given directly, because again channel sections are also of class C as per the buckling classification, and get what is the required area. Then adjust the distance between the channels such that Ixx is equal to Iyy, and ultimately which will give us Rxx is equal to Ryy. So these are nothing but the geometrical properties which are made need to be maintained. Okay, and why is it required to be maintained? There should be a symmetry so that load transfer is perfectly axial. There should not be eccentric load transfer. Okay, that is why we have to adjust the distance between the channels. Check the design force, and this should be more than or equal to factored load. If this condition is not satisfied, then again for the channel sections placed face to face or back to back, you add plates and then repeat the process. For back to back compound section, slenderness ratio should not be more than 40 or 0.6 times the most unfavorable slenderness ratio of the strut as a whole, whichever is less. So you calculate two times the values, one is 40, other is 0.6 times slenderness ratio of strut. Okay, whichever is less value. So this slenderness ratio of the compound section should not be more than the less of the two values calculated. So these design steps will be more clear to you while solving the actual design examples. Okay, and there is a lot of calculation involved in each and every step. So this is a little bit lengthy, but it will give us reliable and safe design.